we're back with you again. We pick up similar triangles or similarity of triangles. Now first let us find out in exploring similar triangles or similarity of triangles what to look for, right? Now two triangles or shapes even then are said to be similar if they have the same similar shape and there are certain criteria which we are going to look at. Now, two triangles are similar if number one, the corresponding angles of the two triangles are congruent. Number two, if the corresponding sides of the two triangles bears the same proportion, by which I mean same constant ratio. Right. Now if you look at these two triangles, you see that in triangle ABC and triangle PQR, we have angle A is equal to angle P, angle B is equal to angle Q, and angle R is equal to angle C, right? Therefore, and triangle ABC is, okay, let's use a symbol, is similar to triangle PQR, right? So this is basically what it is. The properties, what to look for the properties in similar. Properties of similar triangles. What are they? Number one, the corresponding angles must be congruent. Here we see angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, right? This is property number one. The corresponding sides must bear a constant ratio. So here AB by PQ will be equal to AC by PR and BC by QR, right? And the number 3 is they are of similar shape, although size may vary, right? So this is what we have got. What are the properties? The corresponding angles must be congruent. The corresponding side must bear a constant ratio, and the two shapes should be similar but may differ in size. So further exploring similarity triangles, we will be reminded of basic proportionality theorem here also, right? So before going into the relevance of basic proportionality theorem in similarity of triangles, let us find out what are the different ways, how do you decide that two triangles are similar. So here are the axioms or rules to prove that two triangles are similar. Number 1 rule, angle axiom. Now if the corresponding angles of one triangle is congruent to that of the other, then the triangles are similar. But is it clear? Like here, ABC is congruent to triangle PQ, but the reason is the corresponding angles are equal. Now rule number 2, side angle side. If two sides of one triangle bears a constant proportion to the corresponding sides of the other triangle, if two sides of one triangle bears a constant proportion to the corresponding sides of the other triangle, number 1, and number 2, the angle formed by these sides are equal, right? First is, if two sides of one triangle bears a constant proportion to the corresponding two sides of the other triangle, number one, and the angles formed by these sides are equal, then the triangles are similar. This is SAS. And the last property is, if all the corresponding sides of two triangles bears the same constant ratio, then the two triangles are similar. If you look at the figure, if this is rule, if we are to prove it by SSS rule, then AB by PQ must be equal to AC by PR and must be equal to PC by QR. Right? These are now basic proportionality theorem and similarity of triangles and its properties. Now see, here we got triangle ABC and PQR, and we accept that ABC is similar to PQR. So, triangle ABC is similar to triangle PQR. Now, if it is so, then angle B is equal to angle Q, angle A is equal to angle B, and angle C is equal to angle R. Right? Now what we do is, we take this triangle and put it here like this and call it D. Right? Now see what we have done. In triangle ABC and triangle PDE, this is by construction. Correct? One, AB is equal to PD. Number two, AC is equal to PE. And number three, BC is equal to DE. Therefore, triangle ABC is congruent to triangle PDE. Correct? Now, since triangle ABC is similar to triangle PQR, implies triangle PDE is similar to triangle PQR. So if that is so, then angle D is equal to angle Q. Now see, if you take DE and QR as two line segments and DQ as a transversal, see these two angles are equal. So if these two angles are equal, they are corresponding angles. Therefore, the condition of parallelity is satisfied. So they are corresponding angles. Correct? So we can conclude DE is parallel to QR. Now, so if we go back to the statement of basic proportionality theorem, it says that if D and E are points on two sides of a triangle, and if you join DE and QR and if they are parallel, then PD by DQ will be equal to PE by ER, right? So, by BPT, PD by DQ is equal to PE by ER. Now this BPT is also known as Thales theorem. Now we got this. Now how do you connect with similar triangle? See how. Now see, since from BPT we get PD by DQ is equal to PE by ER. Now we can always make them reciprocals. We can write DQ by PD is equal to ER by PE, right? Correct? Now adding 1 to both sides. Let us see what I get. So DQ by PD plus 1 implies that ER by PE plus 1, which implies DQ plus PD divided by PD is equal to ER plus PE by PE. Now see, DQ plus PD is nothing but PQ. So you can write implies PQ by PD is equal to PR by ER. PR by PE. Right? Now, since triangle PDE is similar to triangle PQR, then by property of similar triangles we can write PQ by PD is equal to PR by PE, that equals to QR by DE. Correct? Is it okay? PQ by PD is equal to PR by PE, PR by RE is equal to QR by DE. So this is what I was trying to drive at. So the connection is that the ratio of area of two similar triangles is equal to the square of the ratio of the corresponding sides. Let's see. See, number 1. Now we already said that these two triangles are similar. So since triangle ABC is similar to triangle PQR, we have this relation AB by PQ is equal to AC by PR, and that is equal to BC by QR. This is equation number 1. Now see, area number 1, area triangle AB. See, AB and PS are perpendiculars on side BC and QR of the triangle. So area of triangle ABC is half into BC multiplied by AB. Right? Number 2, area triangle PQR is equal to half into QR multiplied by PS. Right? Okay. Now if we take the ratios, so area triangle ABC to the area triangle PQR, we can write half into BC into AB divided by half into QR into PS. Right? So from here we can write BC multiplied by AB divided by QR multiplied by DS, which we can write as BC divided by QR multiplied by AB by DS. Why you will see. Okay, so far so. Now here, however, in triangle ABD and triangle PQS, angle B is equal to angle Q. Why? Because triangle ABC is similar to triangle PQR. This is number 1. And number 2, angle ADB is equal to angle PSQ. Both are equal to 90 degrees. Therefore, triangle ABD, is similar to triangle PQS. So if so, we can write AB by PQ is equal to AD by PS. Right? And from here, if you compare this, we can write this is equal to AC by PR and also equal to BC by QR. Right? So now we can replace here. So BC by QR multiplied by, so this can be replaced by BC by QR, BC by QR, BC by QR, this. And that is equal to BC by QR whole square. Now, those who are new to this channel, you are with HaveFun&Learn with JP Lata. Welcome to our channel. And if you like the video, please try, share and comment, and try to give a thumbs up. And that's all for today's class. We pick things up right in the next class from here. Right? But till then,